Okay, today's video is on exponential growth and decay. And go ahead and take a minute and jot this down. I will go ahead and pretend that you already did that. And you can press pause on the video at any time if you need to. So exponential growth and decay, the formula for it is going to be y equals a times 1 plus or minus r to the t. So there's a couple of things going on here. I want you to notice that this is still an exponential function like the last one. This is still y equals a b to the x. It's just that they made it so that this b right here, they made the b look really weird, right? Now they have a 1 plus or minus r because this is going to allow us to use a growth rate or a decay rate if we have it. So let's go ahead and talk about what each one of these letters means. When we talk about the A is going to represent your starting amount. Now here, they have a plus or a minus. That plus or minus is going to be dependent on whether this is growing or decaying. So if it's growing, then we put a plus. And if it's decaying, then we put a minus. We'll talk about that one in a little bit, okay? The other thing we have is the R. Now, again, this R is either going to be a growth rate or it's going to be a decay rate, just depending whether your numbers are going up or down. And then T is going to represent time. So I have a starting amount, a growth rate. I'm going to be either using the plus or minus. I got the T. Hey, that Y is going to represent how much you end up with at the very end. So this is going to be your final amount, depending on whether it's going up or down. And then the only thing I really didn't talk about is this one. We did like a little mini lesson in class. And so let me just try to explain that one. So let's say I'm going to raise the price by 20%, right? Normally, when you go to the store, you pay 100% of the price. For sure, you pay 100% of the price. So let me just go ahead and write that just kind of like off to the side. You don't have to write this. You can just watch. Normally, you pay 100% of the price. And if they're going to raise the price by 20%, then that doesn't mean you pay 20%. That means you pay an extra 20%. So not only do you pay the 100%, but we add an additional 20% to the price, which means you're going to pay a total of 120%. That would be your final what you're actually going to pay. All the full 100% to begin with, plus an extra 20. Similarly, like let's say you had like a 30% discount. That doesn't mean you're going to pay 30%. That means you would pay, normally you pay 100%, but then we're going to take off 30% because it's a 30% discount, right? So that's kind of where these numbers are coming from. The plus if it's going to be more, and then the minus if it's going to be less. And this is the rate is going to be like what the either is extra or being taken off. Okay. So why the one? Well, because remember when we're dealing with like a calculator, we don't really use percentages on a calculator. Let me do the first example. What you would do is you would take your 100% and you would change it into a decimal. How do you change numbers into a decimal? You put your decimal at the end of the number and then move the decimal 2 times to the left. Look at the number that I get. I get 1.00, which is that 1. Okay. And for the 20%, if we move that twice, and it would be 0.20. So you're like right here, you would put 0.20. But basically, the 1 means you're starting off with 100%, which is 1. And from there, you're going to either go higher by adding your growth rate, or you're going to go lower by subtracting your decay rate. Okay. All right. So now you know what everything means. Let's go ahead and jump into some of these formulas. They're just asking us to identify the initial amount. And I'm going to want the rate of growth or decay as a percentage. All right. So let's see. The initial amount, remember that the initial amount is always going to be your A value. So my initial amount is going to be A. Which in this case is 13. Let me go ahead and highlight this. Now, as far as my growth or decay rate, remember that would be my R. This is 1 plus R, which is this is my growth or decay rate. Because I'm using a plus symbol, that means it's growing, and it's growing by 0.84. So let me write this. I'm going to write that my growth rate is 0.84. But they said to write it as a percentage. Well, if changing it from a percent to a decimal meant I moved 2 places to the left, then if I want to go from a decimal to a percent, I should do the exact opposite, which means I should move this 2 decimals to the right and put a percent symbol. So this becomes 84% is my growth rate. All right, that will be easier with practice. So let's take a look at another one. Same thing. I want my initial amount. My initial amount is always the number in front of the parentheses, which in this case, I'm going to say initial amount is 700. And then my growth or decay rate is going to be the number stuck to the 1. So this is going to be 1 minus 0.093. Because I'm subtracting, I know that this is a decay rate. And in this case, it's 0.093. But again, we're going to move that decimal 2 times to the right to make a percentage. Notice where my decimal is at is stuck between the 9 and the 3, which means this is going to be 9.3%. Okay, here's where it gets a little, I forgot to highlight this. I'm glad I caught it right now. This was my initial amount. All right, here's where it gets a little tricky. The initial amount is going to be the same, so I'm not going to go too much over this. I know that my initial amount is going to be 2.4. Initial amount is 2.4. What is difficult is usually this is either 1 plus R or 1 minus R. And they didn't write it that way. They just wrote 1.34. So this must have the 1 included on it. I don't want the 1. I want to find just the growth or decay rate. So to find it, I need to get rid of the 1. How do we get rid of 1? Well, we subtract it. First of all, I know that this is going to be a growth rate because my number is bigger than 1, right? 100%, everything revolves around the 100%, which is 1. And if it's more than 1, then it's growing. If it's less than 1, then it's decaying. So in this case, this is going to be a growth rate. But my growth rate is not 1.34. It's 1.34 without the 1. So I'm going to take the 1.34, and with my calculator, I'm just going to subtract 1. You should be able to do it without a calculator, but today it's just going to be a calculator to kind of like avoid confusion. And what I end up with is 0.34. But remember, 0.34 is a decimal. I want it as a percentage. I'm going to move that decimal 2 times to the right. And the answer I get is a 34% growth rate. All right, hopefully that wasn't too bad. Unfortunately, the next one is going to be a little bit worse, but I'll try to do my best to explain it to you. Just like always, the initial amount shouldn't be too bad. That's just the number in front. So I get to write that the initial amount is 5. Okay, from the initial amount, now I need to find the growth or decay rate. Well, that 0.58 is less than 1, so I know that this is a decay rate. And what I did last time was I took my number, which is 0.58, and I need to get rid of the 1. Now, if you type this in your calculator, 0.58 minus 1, what you end up with is negative 0.42. And that negative is there because, again, it's decaying. It's going down. That negative is like literally screaming at you, hey, this is going down. Okay? So my decay rate is negative 0.42. Just like last time, I'm going to take that decimal. I'm going to move it 2 times to the left. To the right. What I end up with is 42%. Now, I know what you're saying. You're like, but Mr. Lechuga, there's a negative. Shouldn't I bring the negative here and make it negative 42%? The answer is no, because I'm calling it a decay rate. And since I'm calling it a decay rate, the word decay is implying that it is a negative symbol. Okay? So when I say the decay rate, you should know that this is a negative 42%, and I don't need to write that negative. It's going down by 42%. I hope that makes sense to you because it is a point where a lot of students will, get it confused. All right, so we're done with the identifying, which hopefully wasn't too bad. Let's go ahead and move on to the last 2 examples. Again, press pause on the video if you need to. I'm just going to move on, assuming that you already copied this down. It says, write a function to represent each situation and find the value after 3 years. Situation A, the attendance at a music festival started at 1,800 and increased by 7% each year. Okay, so if it's, first of all, because I'm dealing with percentages, I'm going to be using an exponential function, which I'm going to go ahead and write y is equal to a times 1. Because it's increasing, I should write plus r to the t. First, I'm going to write the equation. Let's see if I can find some important numbers. I see this 1,800, and I know that this is going to be my initial amount. Remember that my initial amount is my A. The other thing I know is that it increased by 7% each year. This 7% must be my, in this case, growth rate. And growth rate is labeled as R. So let's go ahead and start writing this down. Let's see, I have y equals, and my initial amount A was 1,800 times 1 plus, now that's 7%. I want to write that 7% right there, but your calculator will not handle 7%. So what I'm going to do is I'm going to write that percentage as a decimal. Remember, to do that, you put the decimal at the end and you move it 2 times to the left. So in this case, I'm going to end up with a 0.07 to the t. Now, the only thing left for me to do here to get my formula is, I know what 1 plus 0.07 is. It's 1.07. So I get y equals 1,800 times 1.07 to the t. This answers my first question, which is to write the equation. The equation is y equals 1,800 times 1.07 to the t. This is my equation because I can use any t I want right here. If I want t to be 2 years, figure out what happens after 2 years, I can plug it in. If I want to know what happens after 7 years, I just plug in the 7 right here. Okay. So part 1 is done. They're going to ask you stuff like that on the homework, which is to write the equation. But there is a part 2. Remember, it says I need to write the function. I already did that. And I want to find the value after 3 years. So since I want to find the value after 3 years, I'm going to plug in 3. I get y equals 1,800 times 1.07 to the third power. Now on your calculator, you're going to type it in exactly like that, 1,800 parentheses 1.07. If you're using a TI-30X2S, the only thing is right here, when you write 1.07, close your parentheses, to get to the third power, you're going to type this, 1.07, close your parentheses, and you're going to hit the button that has like the little mountain, or my teachers used to call it like the little carrot top. I don't know why they call it a carrot top. It didn't look like a carrot to me. But anyways, that's going to raise it to the third power, and then you're going to hit enter. Let me go ahead and do that on my calculator real quick and get that number for you. 1,800 times 1.07, close my parentheses, and raise it. Oh my gosh, I just messed up. Now I got to do it all over again. Sorry. 1.07, and I need to raise it. There you go. To the third power. The number that I get is y equals 2,205.0774. And this is where we have to be a little smart about these things. What are we talking about right now? Well, that y is my final amount, and the final amount of attendance. So we're talking about people. And if we're talking about people, then I don't have 2,205.0774 people. That decimal of the 0.0074 people doesn't make sense. So let me go ahead and erase this because it does not round up, and say like, oh, the final attendance after the third year would be 2,205 people altogether. All right, last question for today. It says a $30,000 car loses 14% of its value each year. Let's go ahead and write down the formula for it. Again, I'm going to be using y equals a times 1. Now, in this case, it's either a plus or a minus. But because they said that it's losing 14% of its value, I know that in this case, it's actually going to be a minus r to the t. So it's kind of up to you whether you're going to use the plus r or the minus r, okay? All right, let's go ahead and start seeing what I have. I have a $30,000 starting point. So this must be my A. And it says it's losing 14% of its value. So this must be my decay rate in this case. So let me go ahead and plug in those numbers. That's going to be y equals 30,000 times 1 minus, remember that 14%, we're going to change it to a decimal. So I'm going to put the decimal at the end and move it 2 places to the left. And I end up with 0.14 to the t power. Let me go ahead and subtract those two. 1 minus 0.14, that is 0.86. So my formula is y equals 30,000 times 0.86 to the t power. That is the first question they were asking me for, which was write the formula, right? Now, point of confusion yesterday was, remember, they asked me to do two things. They asked me to write the function. I did that. And they want me to find the value after 3 years. So that means I need to find 3 years worth of this car. So let me go ahead and plug that in. That gives me y equals 30,000 times 0.86 to the third power. And all I'm going to do is literally just type that in my calculator exactly the way it's written there. 30,000 times parentheses 0.86, close my parentheses, and raise that to the third power. I hit enter, and what I get is y equals 19,081.68. All right, just like last time, it is really important that we understand what this thing is, because last time I erased the decimals. This time, doesn't make sense to have the decimals. Well, if this represents money, then this would be $19,081.68. Does it make sense to talk about 68 cents? Absolutely. We do keep those decimals. Now, if it looked like this, it does not make sense to keep all those decimals. It would only make sense to keep the first two, that 0.68. However, you need to take a look, right? You kind of ignored these ones. You can't really ignore all of them though, because you got to look at that 7. If that number right after the first two decimals, because 68 cents works, is 5 or more, then you actually get an extra penny. And this would have changed to $19,081.69 because this was a 7. If that number would have been a 3, then again, the 68 cents is going to stay. If it's 5 or more, it goes up by a penny. That is not 5 or more, so it stays at 68 cents. So I just wanted to let you know, like, hey, you're going to get rid of all the decimals except for 2, but you might round up a penny, or you might keep it at 68 cents because it doesn't round up or down, or it doesn't round up, okay? All right, guys, that's all the time for today's lesson. As always, if you have any questions, please feel free to ask.